Alright, so I've already introduced what a hyperbola is to you, and you understand that basically what a hyperbola is, we've got two parabolas that are kind of like a reflection of each other, right? And using a perfect diagram, this is what we have. I did emphasize the things that we have. We've got the center, where we've got two asymptotes intersecting, and then we said the basic definition of what a hyperbola is. We said this is where if you look at the distance from the 2 points that we collectively call the foci. So if you if you try to subtract or find the difference between the two distances from any given point on the hyperbola, for example, if you focus on a point P, okay, if you measure the distance from F1 to the point P, and then you subtract with the distance from, again, the point P to F2, okay, of course the moduli of these, find their difference, they're going to give you a constant, right? So now it doesn't matter if you get another point again on the hyperbola, or from there again measure the distance to F1 and whatnot, you find that you're always going to be getting a constant there. That's very key and basic for you to understand. Now in this video I want you to pay attention to the variables A and C. Okay, so if you look at A is a distance from the center to the vertice, right? To the vertex of the vertices, okay, of the hyperbola. So that point and that point, measuring from the center, the distance is A. Now C is a distance up to the foci on both ends, okay? That's one thing that you have to understand. Now, paying attention to that, I want you now to get the equation. In this video, I'm not going to go over how we can actually come up with a formula and whatnot. I'm just going to give you the formula, and then we'll look at how we derive the formula in another video. Okay. So now let's pay attention. The equation is as simple as x squared over a squared minus y squared over b squared. And of course this applies when your transverse axis is horizontal, like in this case. This is equal to a 1. Now you're already asking a question to say, where is the b squared, where is the b of the variable b coming from? Because if you look at the diagram that we have, we only have a and c. So I want you to know that the b squared is actually representing the difference between c squared and what? And a squared. Okay. Basically, it was just a substitution. That's why if you look at the video where we're going to derive, you see that b is just something that we just come up with to easily help us remember the equation, right? I think this equation is very simple for us to remember. Let me take you over it again. So the fact that you have x, y, a, b, and then just put the difference and then square them. Simple, right? And then this is equal to 1. Okay, so that's the equation. I hope it has gotten, we've removed it now from our way. We understand what it is. So on the other hand, where you have your transverse axis to be horizontal, in what I've drawn, we just do the opposite, right? So in this case, what do we say about the equation? It will be the opposite. Now we start with y. So y squared over, but what's on the denominator doesn't change. We just swap y squared and x squared. Again, equal to 1. So we know the equations now. You are easily able to remember the equations, okay, that are associated with a hyperbola. Okay. So now let's look at a sample question. In fact, before I go over that, I think there's an aspect that is also key and important. The asymptotes. So they may ask you to determine the equations of asymptotes. So yeah, let me give you an example. So let's assume our center is 0, 0. Okay, and then let's assume the distance. In fact, let's try to come up with a rectangle just here. this rectangle of ours should cut the vertex like that. Even on this other side, and then draw a line like that. Okay, so now assume now the distance from the center going to the left, the vertice. Remember we've said that's A, right? So on this side, if we measure the distance from the center up to that point, that would be negative A. The other side, that is going to be positive A. Okay, that's something that is very basic for us to understand there. Okay, and then we can come up with another variable B, which will now be the distance, measuring the distance in the y. So going up, let's say it's positive B up to that point. Going down, let's say that is point negative B, okay, along the y-axis. So when you get these points, if you look at that coordinate, that's going to be negative A, comma B. If you get this point, that's going to be positive A, comma negative B. So as a smart student, I'm sure you know how to find the equation of a line. It's in the form of ymx plus c, and you can easily find it, right? So the key thing is we need to find the gradient there. The gradient is y2 minus y1 and whatnot. Okay, change in y divided by the change in x attached to x will give us the first part plus our constant c. Okay, now for our lines actually that cut through the center, for the c we're just going to have a 0, so no need of us wasting a lot of time there. So if we try to subtract any that we have, if we try to focus on the one that is along the one that's moving from left to right, sloping down, our y2, let's say our y2 is negative b, minus our y1, which is b, and then again we divide by the x. X, we have our a minus negative a. Okay, what are we going to have? So on top we're going to have negative 2b, on the bottom we're going to have a positive 2a, right? So we have a positive 2a there, and so what you end up remaining with is, that's going to be 2 divide, so you just have negative b over a. If you apply the same principle on this other axis that is sloping upwards, this one is going to be positive b over a. So therefore, in summary, what we're trying to say is the equation for the asymptotes is plus or minus b over a, where the slope going this way is positive b over a, the other one is negative b over a. Those are the equations that will help you determine the asymptotes, right? Okay, so that out of our way, let's now go over an example, a very detailed example that's going to help us apply the things that we've gone through. Okay, so let's assume you've been given 4x squared minus y squared and then is equal to 16. Okay, so the question here is find the foci, so those 2 points f1 and f2, and then the center and the vertices. Okay, so feel free to pause the video and just try out this question, right? A very basic question. Okay, so let me just go over it and just answer for you. Okay, so to start with, we understand that the form of the equation already, as we can see, is y squared. No, this is started with x squared. So this is x squared over a squared minus y squared over b squared should be equal to a 1. Now if we analyze this equation, whenever you start, I like thinking of it in this way. Whenever you start with, or whenever you move in the ascending order of both the x and y and then a and b, this is the horizontal transverse axis. This is the normal way. I like thinking of this as the normal way. And then if you swap and start with y squared, then you understand what you're expecting is going to be a vertical transverse axis, right? Okay. So let's now take the given equation in the form, in the basic form. So the basic principle is we need to have a constant of a 1 on the right. So how do we do that to what we have on top? So we have to divide by 16, right? So divide by 16 if we can have a 1 on the right. Okay? So I'll bring back that equation. For now, let's divide by 16. So what are we going to end up with? We're going to remain with x squared. 4 there, it's 1. 4 into 16 is 4 times. Minus y squared over 16 is equal to 1. Now we have it in the form of the basic form of the equation. Don't forget this is x squared over a squared minus y squared over b squared equal to 1. So our a squared, we can clearly see that it's equal to a 4. They are on the same position. So if we try to find our a, we're going to find plus or minus 2, right, for a. And then for our b squared is equal to 16. Now remember I said your b squared is the same as c squared minus a squared, right? So our b squared, we understand, is matching up with 16. So we're going to have 16 is equal to c squared minus a squared. Our a, whether taken as positive or negative, it is still going to end up positive after we square it. Okay, so ideally a squared in itself is just equal to 4, as we can see. So we'll just put the 4 directly, and then our goal is to find the constant c. So collect the like terms. This is equal to c squared. So c becomes 16 plus 4 is 20. So the square root of 20. So we found our c now. Our c is the root of 20. I think with the confidence that we have at this point, I think if you paid attention to my explanation of the diagram that we had before, this is what we said. This is the center. The distance from here to the vertex, which is the shorter one, is a. Okay, on the other side it will be negative a, of course, when the center, if the center is the origin. Of course, the longer distance is going to the foci, right? Okay, which is the distance c. Okay, so to give the coordinates for the vertices, which is the shorter distance along the x-axis, so understand along the x-axis the y-coordinate is a 0. So the shorter distance, which is a, is -2 and 2. So those are the coordinates for the vertices, the point where we're going to have the hyperbola like that. So for the vertices, we have -2, 0 and 2, 0. For the foci, that's where we use now c, so it will be plus root of 20, 0 and -0. The center is of course the origin, 0, 0. Finding the equations now. How do you find the equation of asymptotes? Remember we said our equation is in the form of plus or minus b over a, right? Okay, so in this case, what have we said about our b? Our b is 16. 16 is equal to b squared. B squared is equal to 16. So our b in itself is going to be plus or minus 4. Now we understand that for the asymptote that's sloping like this, it's positive, this one negative. So we're going to have 4 over our a, which we found to be 2. Now of course we understand for this case, we just have to be smart about it. For the slope, one is supposed to be positive, one is supposed to be negative. So we'll just say plus or minus, and then we end up with 2. So 1 is, now don't forget there's an x there to the equation. So 1 is 2x, the other one is negative 2x. These are the equations of our asymptotes for this question, right? Yeah.